Welcome to this episode of the Civil Engineering Podcast, the first podcast dedicated to helping civil engineering professionals succeed in work and life. I'm your host, James Taylor, and in this episode of the Civil Engineering Podcast, I'll be talking with Clint Steele, RPENG-MECH, Senior Mechanical Engineer at Cylite, and advisor in business strategy, education content, AI, and ML strategy at Hotseat. We're jumping into Clint's journey as a mechanical engineer and the inspiration behind his book, Global Engineer. Clint will share insights into how an engineer's background influences their work, exploring culture, economic, and organizational factors that shape engineering practice. We'll also discuss the core attributes of good engineers, including framing, systemic thinking, and first principles. And we'll also discuss practical strategies for developing these attributes effectively. Clint also shares his perspective on the role of AI and machine learning in shaping the future of engineering on a global scale, and offer valuable advice for engineers seeking to excel in the ever-evolving landscape of engineering. Get ready for an engaging conversation filled with insights and actionable advice for engineers looking to broaden their horizons, make a meaningful impact in the world of engineering. It's now time for our Civil Engineering Conversation of the Week with Clint Steele. Clint, welcome to the Civil Engineering Podcast.
Thank you for having me.
Starting off, can you tell us a little bit about yourself and your career journey as a mechanical engineer?
Sure. So it was a bit serendipitous. When I was a teenager and we were on holidays and I was a bit bored, my mother, for one reason or another, decided to buy me a hot rod magazine. And this magazine had a technical tips section in it. And that was very much focused on the application of scientific knowledge and how, well, in this case, you could make a car go faster. But what I became interested in was the way we could use our understanding of the natural world through science and things like that to bring about any outcome that we wanted. And I became obsessed with that idea. And then I found out there was engineers that did that. So I enrolled in an engineering degree. And then towards the end of that engineering degree, I came across a thing called probabilistic design, which for me was a bit novel. But for a civil engineer, it's probably not so novel, because civil engineers deal with this a lot more than mechanical engineers do, given the volatility in natural phenomena, and you can't always trust soil either. You know, you think it's one thing, but it might be something else. So There's always a bit of randomness there. So I did a PhD in probabilistic design, and then I went out into the real world to work as a design engineer. And since then, I have worked in academia, I've worked in a number of companies, and I've also worked in China and Thailand, and so a number of companies, number of industries, number of countries, and from that I've developed quite a fascination with how engineering is practiced at its most fundamental level, regardless of the industry or the location.
So a lot of background there of all different, you said, all different countries, all different areas, and all different industries, and some of that ties into my next question here of your book. It's called Global Engineer. You talk about working in Thailand and in China. This book is making waves in the engineering community. I believe it's just released recently, correct?
Correct, yes.
Yeah, so what inspired you to write this book? And so two-part question. What inspired you to write the book? What do you hope engineers will take away from it?
Gotcha. So what inspired me was research that I did when I was in academia. I was working in China, and it was fascinating because even though I was working in China, and even today, but certainly at that time, there were people from all over the world who were working in China. So it wasn't just Chinese you were working with. It was very global. And it was fascinating to see how different people worked and how they sometimes worked together and how sometimes they didn't work together. And then when I went into academia, I needed to find something to research. And so I decided to investigate how people's background affects their engineering practice. And then from that also how people could become better engineers. And I found it interesting, and I thought it's something that's really worth sharing with other people. And so thus the book was written. And the one thing that I probably want people to take away from it was that I guess no matter where you're from or where you work, you can take control of your development as an engineer. You're not the victim of your circumstance or anything like that. It is entirely possible for you to understand what makes for an excellent engineer and to learn those things so that you can then develop yourself and be the engineer you want to be. I think that's the one thing I would want people to take away from that book.
So basically anyone can be an engineer, anyone can take the practice that they need to really grow as an engineer, to be a great engineer.
Correct.
No matter your background, what circumstances you faced, anything else, you're able to make that difference in being an engineer.
Absolutely.
So in your book, you discuss how an engineer's background, like we were just saying, cultural, economic, organizational, affects their work. How do you think this plays out in practice? I know you said it doesn't matter what that is, but how do you see this playing out?
So it plays out unconsciously. And I think if you've ever had that situation where you thought, why is that engineer just so good at what they're doing? Like everything they do, they seem to make the right decision. Everything seems to go well. And then maybe on the other hand, you've met other engineers where you say every call they make, just not quite right. And the reason for that, I believe, after doing my research, is that their background has made them ideal for a particular context. And they happen to be in the right context or they're not in the right context. And so that's how it usually plays out, where you don't quite know why this person's a good fit or they're not, because they're just responding to whatever their background encourages them to do. They haven't had that ability to sort of take a step back, understand what the core principles are of good engineering practice, and then apply that in a more universal or global manner. So that's how I think it plays out. And I think most people here listening to us have probably maybe even experienced it themselves. Like, I remember that time when everything was going great. And then you've had those times where all your decisions don't seem right. I think another time when you might see that happen is where a company changes rapidly and there's somebody who used to be very successful in that company, and yet the way they used to do things is no longer applicable. They're still the same engineer they always were, but the environment has changed around them. And because they just sort of responding somewhat instinctively, instead of being able to take a step back and apply those principles, they've gone from being a great fit to not such a great fit. Could also go the other way, but I think that's how you often see it play out, where some people just seem to have this magic about them, and some people unfortunately don't.
It's very interesting you say that, because I know a lot of times in engineering, right, you start out, you graduate college, university, you're like, okay, I'm going to become an engineer. I go through my practice and learn the things over the next so many number of years before you become a professional engineer. When you see success in those people, a lot of times a company will promote them into a new role, a project manager or something else, where that might not be their forte, their expertise.
Indeed. Yes.
But so there's kind of two different pieces of the company can change, or you're kind of promoted up through a level where maybe you're not prepared for or ready for.
Yes, I agree entirely. That I've seen that happen myself. Yes.
So what things do they need to do during that process to make sure that you're staying up with what that role is, what those things are changing? How does that engineer make sure that they're ready for that job that they're in?
Yeah, so I think the key thing is to focus on the fundamentals. And so in my book, I talk about the sort of the three things that really do make for the excellent engineer, and that's your ability to frame a problem, your ability to think systemically, and your ability to apply first principles. When you're aware that they're the sort of the three core things, once you're aware of them, you start applying them almost. You can't help but apply them because you're now aware of them. Once it's pointed out to you, you can't stop. And so you then realize that if you're in a new situation, maybe the way you've always been framing problems is not the way you should be framing them now. You say, hang on, I've always taken a problem as is, and I've looked at it from this perspective. Maybe I now need to look at it from another perspective. Systemic thinking will also help you because you now think, all right, I've got to think outside just where I am. I've got to think about other things that could be opportunities and other things that could be risks. And so you broaden your perspective. And so even though you're in this new situation, you can now see the bigger picture and make a better decision. And the third part is first principles, and that's essentially theory. If you always get down to the core theory that's basically applicable everywhere, then that's going to help you through as well. So that's what I would say would be the things for that somebody who's found themselves suddenly promoted and the whole environment seems different. Remember those core principles. And if you're now managing people as well, be mindful of how the people you're managing might or might not be applying those three attributes themselves.
So how do you develop those attributes effectively?
So framing, I think, is where you realize that you take a problem, and if you might realize you've always just taken the problem at face value. You've never thought to view it from other perspectives. Or you might realize that you've always tended to frame, but you haven't quite realized it. You've done it unconsciously. So next time you take on a problem, you say, this is the way the problem was presented to me. This is the way I've perceived it. Why did I perceive it that way? Is there perhaps another way I could perceive it? And then once you do that, then you think about other perspectives or other ways you could view the problem, and that will automatically improve your framing ability. Systemic thinking is probably a simple case of saying, what are some peripheral things that I haven't thought about yet? Just relax, take your time, and think what else could be at play with whatever problem you're facing. Talk to other people as well, people in other departments, people above you, people below you. Just say, are you aware of this? What are your thoughts on it? Do you have any concerns? Is there anything you're hoping would happen? And those will also expand your perspective, and then straight away you're thinking systemically. The first principles can be a little bit tricky, depending upon who you are. There are some engineers out there who studied to pass the exam. They didn't study to actually remember and understand.
Right.
If you're in that scenario, you've got a little bit of reading to do. But probably more important is you can say, before we make a decision here, I want to see some numbers. I want to see some numbers to justify this decision. And the only way you can generate numbers is probably through some kind of formula. And that's going to require some kind of first principle. So that will get you in the habit of applying first principles. That's probably a somewhat shortened version.
Sure.
But that's the recommendation I can give to somebody who wants to develop those three principles of framing, systemic thinking, and applying first principles.
And they can read more in your book,
Absolutely,
obviously,
yes,
about these
yes,
things. So,
yeah.
So just a reference to that resource. Clint, do you think one of these three is more important than the other, or do you think it's a case-by-case basis depending on the individual?
I get asked that question a lot. And the other question, when I was teaching this in an academic context, the other question I go is, which one am I meant to do first? Because people want that sort of prescription. And I do think it's very much a case of, as you said, case by case. I'm not sure if you've heard of a guy called Edward de Bono, he was the guy who came up with the term lateral thinking. And he also came up with a thing called 6 thinking hats. And this is where you sort of think, am I meant to be sort of logical here? Am I meant to be emotional? But there was another hat called the blue hat, which is where you think about the best way to think at this time. And so when I spoke about these 3 things, it's probably worth pointing out this notion of the blue hat, which is where you engage in metacognition, where you think about the way you wish to think. And I think, and that comes back to it being by a case basis. And so I would agree entirely with what you said there, that it is very much you got to do it on a case by case basis.
Yeah, each person is different in their own, their own assets, their background, like you talked about, the culture, economics, everything else, and where one might be able to easily do the framing, they might not be able to do the first principles, or vice versa.
Yes,
that allows them to grow as an engineer.
Absolutely.
What are some common issues that engineers should be aware of as they aim to become global engineers?
Sure. So I think the first one was probably something we alluded to earlier, where we said if you're the kind of person who maybe studied to pass the exam, if you want to work as a global engineer, you do need to understand that which is common everywhere, and that's first principles. So I think the most common thing I've seen are those people who said, "Oh, I should have paid more attention," or I should have used a deeper approach to my study than just passing the exam. So that's a bit of a challenge for some people. But you can always just have that in front and mind, or front and center in your mind, that it is something you can develop. The second one is that I have seen people who have felt, and this is what we were saying earlier about no matter where you are, you can take control of your own development. The second issue I have commonly seen is where engineers, particularly young engineers, have said, I don't have a mentor, or I can't find somebody in the right company to show me or take me under their wing and show me everything. I think you can. There are so many resources out there. There are just so many books on engineering if you go and look for them, documentaries, things like that. You can watch documentaries on some of the greatest engineers in history, and you can learn from them that way. So don't feel that you're limited in that sense. And the third one is a lot of people sometimes think they can't change. And just remember, improvement is a type of change. And if you want to improve, you'll have to change, and you can change if you want to. They're probably the 3 common issues I see when people want to globalize their skill set.
I like your second one, and it's one of the things that I've always said is like you're in charge of your own development. Like,
Yes.
when you become part of a company or a government agency or whatever it is, like I think especially right out of school, we think, okay, we've gone through school and we've been given this information, and we think that that's going to continue. I'm going to continuously be developed and trained. And yes, you're going to be continually developed and trained, but it's not going to necessarily be in the specific area that you're thinking, or it might not look the same way. We go through the education system and everything is theory, and it's all, everything's in the box by the book. It's, these different things. Once you get into the real world, there's other ways of learning where it's on the job learning obviously is great, but that's one of those terms that people don't necessarily like to always have. But realistically, everything that you do, there's probably something learning from it. One thing I like to do is each day is to be thinking about that, what's something new that I learned today, and even being in the industry for 18 years, it's something that you can continually learn day in and day out. If you practice it, if you put your mind to it, like you said, you're responsible.
Yes. For
your own development.
Yes. I think that. Go ahead.
Yeah. I was going to say, any thoughts? I mean, that seems to be the basis of a lot of this is you got to take your own life in your control.
Yes. And I guess the only thing that I would add to that is, remember, there are a lot of resources out there. Find those resources. I think some people, I did take control and I decided to do this, and this. Think, why did you decide to do those things? That's not, where did you get that idea from?
Right.
So there is certainly a lot you can learn from others. And I think, like I said, learning every day also, and I don't think this, or maybe it's a more common problem than I realize, you might also be relearning. Even when you think you've learned it, you still make that mistake. I made that mistake 5 years ago. How did I do that again? So it is always worth reflecting, because sometimes it takes 3 times before it really sinks in.
Can you share an interesting example of how background has been found to affect engineering practice?
Yeah, I can actually. This was something during our research. So when we were conducting the research, what we actually did is we interviewed a number of engineers from different disciplines who had worked in what we called mixed teams. Primarily, because it was in China, obviously it was easy to look for predominantly Westerners who were working in China with Chinese. And before we did that, we had to do some research on the literature, on what people had found about essentially the differences between Western and Eastern psychology. And one of the fascinating things was somebody from an Eastern culture, if you show them a picture, like a painting or something like that, they're much better at recalling the things in the periphery. Whereas somebody who was Western is more likely to notice the things in the middle. And the psychologists argued that the reason for that was that in Eastern culture, it's not simply what is said, it's also who says it and who else was around. You have to very much think about the cultural context. Whereas Westerners are more inclined, at least we like to think, that we're more fact-driven.
Right.
It's all on a spectrum, but generally speaking, it's more the information is more important than the context. Therefore, we were anticipating that Chinese engineers would show a greater ability at systemic thinking because they were used to thinking about context and things like that.
Right.
But the research found the opposite, and we were trying to work out why. And we found a number of engineers who were able to explain this, because when they were working with Chinese engineers, when these Chinese engineers had gone from a Chinese company to a Western company, they had noted that the change was in the Chinese company at that time, because it was a developing economy. This was some time ago when I did the research. They were still treating the engineers very much like factory units. It was a bit like a Dilbert comic strip, where each engineer was in their little cell. They were passed something to do, and they did that, and then they passed it on to the next engineer. It was very much a factory. So what had happened there was that the organizational influence had overridden the cultural influence. And so there were these two things at play. And so in a sense, that was quite exciting because it showed very clearly how you can change what you can change, because this characteristic had been developed, had been a characteristic we were expecting had been overridden by the influence of a company as opposed to the culture. So that's probably the most interesting thing I've seen play out. And what was worth noting, that the engineers we spoke to who saw Chinese engineers transition did find that they were able to get that skill back, and they did make comments about their ability to be actually quite broaden their consideration as they got training in that area.
That's real interesting. That's pretty cool. Yeah, and not something that I would think about either. But you brought it up of Eastern, versus Western culture, of the peripheral versus, the main thing, and man, that really framed that very well. From your experience, what are some practical things engineers can do to work better with teams from different backgrounds?
So if you read up on teams theory, and the good thing about teams theory, it's quite an established area of research. I think what you really want to push for is a thing called shared situational awareness. Team theory says that what you really want is shared cognition, where everybody not only knows what the other engineer is doing, but probably how they're thinking about it. That's a pretty tight team. I think that would be hard to get in a mixed team context, or in a in that sort of global context. But definitely shared situational awareness is the key thing, because we all contextualize things differently. So we hear the same message, but our priorities are different. And so therefore the way we interpret things will be different. And so taking action to make sure everybody does have the same understanding is probably the most important thing. Okay. And the way I've seen that work best is to you basically ask clarifying questions or even scenarios. So if this happens, what do you think we should do next? And you just see how everybody responds to that kind of a question. So, for example, according to this agreement we're about to sign, if we don't meet the deadline, which company is the one that's going to incur a fee or something like that, and just see what somebody says. Or, if we do dig here and we discover some solid bedrock, what does this mean we're going to do? And you just sort of ask those questions to see that you get that shared mindset. That's what I found to be the best way, is to, you say it, and then you just ask a few probing questions and scenarios. Say, if this, what do you think will happen? And make sure everybody answers in pretty much the same way.
And it also helps their development as well, right? Because, with that, you're not just getting someone on the same page as a team, you're also allowing them to think through things better, to kind of develop that and grow that team together as a whole.
Yeah.
What do you think are the most important skills or mindsets for engineers who want to work internationally?
Gotcha. So I guess, as I've probably said a few times now, the fundamentals, really understand the fundamentals, because they're, by definition, they're fundamental and therefore they're universal. I think when we were doing the research, we did often ask people about who failed in these mixed teams in this global context. And they were often just simply described as stubborn, and said these were people who were not prepared to accept that there could be a different way of doing something. And so they just wanted to do things the way they had always done it. So I think if you're aware of the fundamentals, at least, because that's probably your, that is your boundary, we can't break the laws of physics. Sure. Or, we know that this is a good way for an engineer to work. We've got to think about these systemic issues. We've got to make sure our decisions are based on first principles. And, have we framed this problem the right way? So they're things you can always apply. But from that point onwards, you're then able to say, well, maybe everything else I've done isn't it's not necessarily the best way to do it. There are other ways of doing it. You become more open to other perspectives. And then you might realize why are these people who are from a different culture from my own framing it the way they're framing it? And it might help you understand their perspective as well. So once again, the fundamentals, in some sense, it's paradoxical, allow you to be more flexible and look at different ways of approaching things.
Flexibility is, and not just internationally, but even, in anything that we do, there has to be flexibility with what we're doing as engineers, because, even across boundaries, government boundaries here in the US or wherever else, you have different regulations. You have to be a little bit more flexible about how things are, even working with clients. Like, each client is different. Each person you deal with is different. If you are stuck in your ways of this is how I'm going to do things, you're not going to grow as an engineer either.
Absolutely.
Is that a correct way of
absolutely.
that?
I think when we say global, we do often think sort of from one country to another. But within any country, there can be a huge diversity of economic development, how old the company is. If you're moving from an established 100-year-old company to a startup, you can expect some phenomenal differences in culture. Yeah. And to really understand those fundamentals, once again, would be very helpful. In fact, I would argue that somebody going from a very established company from one country to another country would probably go through less transition pain than somebody going from, say, a very established company to a startup or vice versa. So there is definitely diversity within with anybody's country. So absolutely, that flexibility is going to serve you very well.
So here's a question related more along the lines of industry trends right now, what's going on with AI and machine learning. So How do you see AI and machine learning influence the future of engineering, especially as it pertains to the global context?
Gotcha. So I think what I have found fascinating with AI of late is its ability to translate. And one thing that I've certainly experienced working with and in other countries is that often, let's be honest, engineers aren't renowned for their language skills. And it's often somebody else who has to do the translating. So you've got these two engineers who could get so much done if they were able to speak each other directly, but you're talking through a translator who's probably not the most technologically savvy of individuals. And so I think AI is going to allow engineers to speak directly to other engineers in other parts of the world. So I think a lot of engineers are going to find that as employers realize that there are certain parts of the world that have skill sets that are very well developed, like what economists call a comparative advantage, you're going to find that your company will be encouraging you to liaise directly with engineers from those countries. And because it will be a direct translation now, you won't necessarily have that human element to do perhaps a little bit of cultural translating for you as well. So I think engineers are going to find that through translation, they're going to have more opportunity to deal directly with engineers all over the world. That's the first thing. And I think that's the more short-term thing. I think with AI, I am looking forward to it automating a lot of the grunt work that we still have to do. Setting up simulations, doing our drawings, things like that. I would love to be able to say, can you give me a third angle perspective on this part and highlight this one? And I think change this dimension over here to inspect on at the start of each batch or something like that. And just have the AI generate these things much faster than I can click. That's, I think, and that's a bit longer term because I think the data won't necessarily be on hand to train the AI, but it's only a matter of time until somebody starts collecting that data. And a lot of those things that where we take a lot of time to set something up and then you press the button and you let it run, will hopefully be automated.
Do you think that makes the engineering industry even more important because you have these AI, machine learning type things creating it, that engineers really need to understand the fundamentals behind those aspects to make sure that the things that the AI and the machine learning, those things, make sure that what they're doing is correct?
Yes, I agree. I think even now, you still need those fundamentals to make sure that answer makes sense. Every time I do any simulation or anything like that, I've always tried to come up with a very much a simplified model, but a hand calculation. So I've at least got the orders of magnitude. And I guess with AI, you've got that extra level of possible misunderstanding. Sure. And once again, you still need to have some ability to verify with your orders of magnitude that the answer looks right. Absolutely.
So lastly, what's your final piece of advice for engineers looking to broaden their horizons and excel in a global engineering landscape?
Gotcha. So I guess I've said it a few times now. Once again, it is understand the fundamentals because that gives you a great chance to contextualize other perspectives. So if you're anywhere in the world, if you always take it back to those fundamental principles and those core attributes of engineering practice, then that will allow you to better understand why other people have done what they've done or why they suggest what they suggest. Also, think of everything as a spectrum, which I said earlier when we were comparing Eastern psychology and Western psychology. It's not as if they represent two extremes of anything. The spectrum could be out here and maybe Western and Eastern are here, but the spectrum could very well be this wide. So think of everything as a spectrum, which means there's no right or wrong, but just degrees of certain tendencies. And then it's a question of which tendency is probably best in this context. And then that will help you better understand the context and things like that so that you can then make the decision that is best given the situation that you're in.
All right, welcome to the CE Hot Seat. Clint, you ready to go?
Yes, I am.
All right. Do you have any specific rituals that you practice every day? For example, do you have a specific morning ritual or lunchtime ritual, things that you do consistently daily that contribute to you being a successful professional?
Gotcha. So I don't have rituals as such, but I make sure that I routinize those things that are sort of essential but not necessarily important. So I try to go to bed at the same time, get up at the same time, go to work the same way, so that I've got more free time to do those other experimental things that reveal opportunities for the future.
What is one book that you recommend to engineers regularly, or just one book that you have found to be extremely helpful in your professional and or personal development?
Gotcha. It's a book called How We Got to Now by Stephen Johnson. And it's basically the history of the world from the perspective of technology. And what it shows is how technology triggers technology, and that as an engineer, it's sort of like we're sort of a mechanism to keep technology going. And if you want to be in some area that's exciting, then look for the trends in the technology and then ride that wave.
Thinking back on your managers of the past, picture your favorite manager or managers. What made them your favorite?
It was a manager when I was working in the automotive industry, and he actually had a very good handle on company policy, because this was an automotive company, so it was a very large company full of policy, but he was also aware of good practice as an engineer. And from that, he could find the best approach to any problem that was aligned with the policy and still congruent with good engineering practice. And that was, I think, essential in the complicated environment of a large corporation.
I've got one final question, and that's the critical civil engineering career elevator advice question. And so what that is if you got into an elevator with a civil engineering student and had about 30 to 40 seconds with them, what career advice would you share with them?
I'd say always focus on the fundamentals, because they don't change, and then follow the trends in the technology. Look for those technologies that are arising, and they're the ones you want to latch onto, because you can just latch onto that technology, and as it grows, it will take you with it. So don't get wrapped up in the way things were done. Be mindful of what's happening now and what looks like it's going to be a big thing in the future.
Clint, thank you so much for joining me today. Where can our listeners connect with you?
Sure. I'm always on LinkedIn, and I'm always willing to connect with people on LinkedIn. You can also find me at my website, www.cjsteele.com, and I'm always keen to connect. So I'd be very much looking forward to connecting with anybody out there who wants to talk a bit more about engineering.
And make sure to pick up a copy of your book too, right? Global
I'd
Engineer?
like to say yes. I agree entirely. Good suggestion there, James. I like
There we
the way
go.
you think.
Awesome. Well, thanks, Clint. It's been great talking to you today.
You too.
Please remember, you can find the show notes for this episode at civilengineeringpodcast.com. There you will find a summary of the key points discussed in today's episode, as well as links to any resources, websites, or books mentioned in this episode. Until next time, I wish you the best in all of your civil engineering endeavors.